Hello everyone, this is Mr. Donaldson, and we're going to start a series of videos about transformations. As you can see on the screen, there are 4 transformations listed. We have a translation, which is a slide, a reflection, which is a flip, a rotation, which is a turn, and a dilation, which is to make something larger or smaller. This first video is going to talk about a translation. Before we get started looking at translations in more detail, let's go over a few vocabulary terms. First, we have a transformation. This is the mapping or movement of all the points of a figure in a plane according to a common operation. We have a translation. This is a transformation that slides each point of a figure the same distance in the same direction. And we have something called congruent figures. These are figures that have the same size and shape. As mentioned before, today's lesson is about translations. And basically, a translation is sliding an object. Here are some examples. In the first example, you can see that this shape here was slid to the right. In the second example, we have the letter R, which was translated diagonally. And in the last example, we have a triangle in quadrant number 2, and it was moved or translated to quadrant number 4. These are 3 examples of translations. Here's how a translation works. We're going to start with a triangle that's located at the points 1, 2, 2, 4, and 2, 0. As you can see, this triangle is already on the coordinate plane. And we want to translate this shape 5 units to the left and 2 units up. What this basically means is we're going to take each point A, B, and C and move it 5 units to the left and 2 units up. I'll zoom the picture in a little bit so we can see a better look at it. So first I'm going to start with point A. And I'm going to move that point 1, 2, 3, 4, 5 units left, 1, 2 units up. So here's our first point. We need to label this point. We're still going to label it A, but we're going to put a little apostrophe, and this is known as A prime. Whenever you transform shapes, that's how you label it. Okay, now to point B, we're going to go 1, 2, 3, 4, 5, 1, 2. Okay, here's our new B point, and remember it's B prime. Now our final point, point C, 1, 2, 3, 4, 5, 1, 2. And we're going to label this C prime. The only thing left to do is connect the dots, just like when you were young. And here we go. Here's our new triangle. We have translated the first triangle 5 units left and 2 units up. This is how you'll do any shape. It can be a point, it can be a triangle, it can be a pentagon, whatever. Just move each point how many ever spaces it tells you to translate. Now we're going to look at the same problem in terms of algebra. When we move left to right, that's changing the x value of our ordered pair. When you move left, you subtract. When you move right, you add. We moved left, so we're going to subtract 5 from the x value. Up and down is the y value. If you move up, you add. If you move down, you subtract. We moved up, so we add 2 to the y value. It would look like this. X minus 5, because we moved left 5, and y plus 2, because we moved up 2. And we're going to do this with each of our points. So for our A point, we have 1, and we subtracted 5 from it, comma, 2 plus 2. And if we actually work that out, A becomes 1 minus 5 is negative 4. 2 plus 2 is positive 4. Now with our b value, b is 2 minus 5, comma, 4 plus 2. 2 minus 5 is negative 3. 4 plus 2 is 6. And we're going to finally look at our c value. 2 minus 5, comma, 0 plus 2. So 2 minus 5 is negative 3. 0 plus 2 is 2. And so once we translate it, we should find that our new ordered pairs are there. Negative 4, 4, negative 3, 6, and negative 3, 2. If we look back at our translated figure, let's count our points. We're going to first count to A. We have negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4. So that point is negative 4, comma 4. Just like it was when we worked it algebraically. The next point B, start at the origin. Negative 1, negative 2, negative 3. 1, 2, 3, 4, 5, 6. So that point is negative 3, positive 6. Just like it was when we worked B algebraically. Finally, for C, start at the origin. Negative 1, negative 2, negative 3. 1, 2. So that was negative 3, 2. And this matches up with what we just did algebraically. And that works for any shape. The final thing we're going to learn about translations is when you're given a graph and it already has translated figures on it. And we need to find out how it was translated. What you do with a problem like this is you start with your original shape and count each point to see how you got to the new shape. Now you may be asking, which one do you start with? Well, remember, when we write it as an apostrophe, which that would be E prime, that's after it's been translated. So in this case, we would want to start with the other shape. So what we're going to do is basically count. Count left to right first, and then up and down. The reason you count left to right, because remember that's for x, and in an ordered pair, x is the first value. So I'm going to start with point E, and I went 1, 2, 3 units left. So it was left 3. Then it's 1, 2, 3, 4, 5, 6. Down 6. So to explain it, I would write something. Point E was translated 3 units to the left and 6 units down. And if I go back and check, I should see that every point is the same. With F, we've got 1, 2, 3, 1, 2, 3, 4, 5, 6. G, 1, 2, 3, 1, 2, 3, 4, 5, 6. H, 1, 2, 3, 1, 2, 3, 4, 5, 6. Every point is left 3, down 6, and that's what I would write. How would we show this algebraically? Remember, we start with x, and it's either plus or minus. We went left 3, so it's x minus 3, comma, and y, it's up and down. We went down 6, so it's y minus 6. And that's how you would show a translation algebraically. Remember, if you have any questions, you can email me, you can send me a message on Twitter, or you can just ask me in class. Hope you understand translations now.